This is geometry 1.5 using the distance formula. You've done this distance formula before, definitely in Algebra 1, definitely in middle school, but you need to know 2 points. When you're given 2 points, you can calculate the distance between them. So point number 1 is considered x1, y1, and point number 2 is considered x2, y2. And we're going to plug them into the formula as is. Notice that the x's go together and we subtract them. The y's go together and we subtract them. We square both of those values and add them together. It's actually just like the distance, or Pythagorean theorem, like we've talked about before. When we take the square root, we're getting rid of the square, and then it's c squared equals a squared plus b squared. So we'll come on down. If you want to notice that we have a QR code, you could watch a little video on your own that kind of talks about the same type of thing I am. It's not by me, it's by a different author, so your choice if that would be beneficial for you, just not right now. Okay, what is the length of RT? Well, we have the points R, 3 to the right, 2 up, put in your dot, that's your R, and your T, 4 to the left, and 3 up. So notice in this case that this line is not quite horizontal and it's not vertical. If it's horizontal, you could count, but we cannot count diagonally. You cannot just count over, which would be the same amount as if it was that way. So now we have our points. This would be considered x1 and y1, x2 and y2. And we're going to use our formula. If you recall, it was the distance is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're going to plug our numbers in. x2 is negative 4 minus positive 3 squared, y2 minus 2 squared. So you have to show that step. To receive credit, you've got to use that step. Now, if you want to be calculator dependent, you could do a little bit of that here. You could plug the inside, which is often called a radican, you can plug that into your calculator. So I have a parenthesis, negative 4 minus 3, close the parenthesis squared, plus 3 minus 1, 3 minus 2, which is 1, squared, and that whole value comes out to 17. I need to see that that calculation comes out to 17. Don't skip that spot. And if you want to turn it into a decimal, you could now take the square root of the 17. Oh, what did I do wrong? I got too many buttons here. Square root of 17. 4.12. We like to round to 2 decimal spots if you're going to use a decimal. 4.12. Now we're going to talk about doing this with variables. Variables make it a little bit more complicated thinking. But we still use the same idea. x1, y1, x2, y2. So we'll use our formula, which we have up here. x2 was c minus x1 was 4c squared plus 0 minus 0. Now, unfortunately, a calculator is not going to help us here. So we got to use some brains. So 3 minus 4. Well, sorry. That is 1 minus 4, which gives us a negative 3. And that is a C. So that's going to be negative 3c squared. Over here, of course, 0 minus 0 is 0, and you square it, you get 0. Now, before you do the calculations, we should look inside the parentheses. We need to square the negative, square the 3, and square the c. So that's going to give us 9c squared. And then you know that if you take the square root of 9, and you take the square root of something squared, that would be your answer, 3c. We can do the same thing down here. You're welcome to pause the video, and you could do your calculations. And then you can turn back on the video and see if my process matches yours. So you're welcome to pause it. So we're going to do the calculation of the length. Length is distance. So we know that distance is x2 minus x1 squared plus y2 minus y1 squared. That's a long square root. We know that this first value is x1, y1, x2, y2. Label your points. Plug in your numbers. We got 9d minus 5d squared plus d minus 2d Now we need to work inside the parentheses. We can't use a calculator here necessarily. So 9 minus 5. 9 days minus 5 days is going to give us 4 days. One minus 2 gives us negative 1. D. Now we're going to square the 4 and square the D. Square the negative, square the 1, so it's positive 1 total, and square the D. So now we have like terms. These like terms can be added. You take the 16 and the 1 and add that together. Now when we think about these values, can you take the square root of 17? I can take the square root of 16, but I can't take the square root of 17. That's a crazy decimal, I don't know. But do you have another value squared? So you can take the square root of something squared, but leave the 17 inside. That's our answer. That's the distance. We can turn the page. And here we're talking about midpoint. So the midpoint is going to divide a segment into two congruent segments. So a figure, it cannot have arrows on it. It has to be a segment. Now if you know you have a midpoint, that's going to be exactly in the middle. And the notation that we use for that on the figure are these tick marks. That indicates that both of these smaller segments are the same measurement. So if this was A, C, and B, you could say that AC with a line over it is congruent to BC. It divides it into two congruent segments. Okay, the word bisect means the same thing. You are going to bisect it. You're going to cut it in half. The point is a midpoint. By cutting it in half, you are going to bisect it. So that is the exact same thing. So if you have a bisector, a lot of times a bisector is a point, a ray, or a line segment, and that is considered your bisector. A point can be a bisector, and it makes the two segments the same. You could have a different segment. And a lot of times we may draw a line through that. It could even be a segment. It could be a ray, just goes from here out. Anyway, if that is a bisector, then it has created them in congruent parts. So here's another video you could watch, just about 5 minutes worth, and they will explain how to put this type of question together. But notice that this is a segment that has a bisector on it, which is a ray. The tick marks tell you that these two measurements are the same, and we want to know the total distance. Well, if this is 2 1/4, and this is 2 1/4, then I know the small part plus the small part equals the big part. That's a segment addition postulate. And we've learned that 2 1/4, substitute in 2 1/4, is the length of AB when we add those two together. So 4 2/4. You may realize that 2/4 is the same thing as a half. So you could call that 4.5. I would assume you're using a calculator that way. You have 2 of the fourths, and then you know you can reduce. 2 goes into 2 once, 2 goes into 4 twice. Here's the trickier one. Here we have variables. We know that C is the midpoint. Read your directions. Understand what you've got. You've got to study the figure first. So C is the midpoint of the big segment. We want to know the measurement of just one side. We're not interested in the expression. We want to know its actual length. Now, in the past, we've done things like the segment addition postulate. Small part plus small part equals big part. But that's not going to work here. We don't know the big part. So we're not going to add the two smaller ones together. If this is a midpoint, then I know I have congruent segments. And if they're congruent, then they're the same measurement. They're equal to each other. So I know that BC is going to equal CD because we have a midpoint. So 3x minus 2 equals 2x plus 3. Subtract your 2x over. Reduce what you can. So now you have 1x, the negative 2, and the 3. This is the work I would expect to see, not just answers. I use my calculator. Not good enough. I want to see your letters, your numbers, and your algebra. So x is 5. You get all excited and you bubble in the multiple choice answer of 5. But you did not answer the question of what's BC. BC is 3x minus 2. So we're going to say 3 times 5, because that's what x is, minus 2. 15 minus 2, and we get 13. There you have it. Off to the homework.